Okay, for the sake of time, I think we will get started. Welcome everyone to the New Jersey Climate Change Resource Center's Special Climate Academy event, focusing on a newly released report entitled Ecosystem Service Valuation Approaches and Carbon Mitigation Consideration for Garden State Agriculture. My name is Carrie Ferraro from Rutgers University, and I will be your moderator for today's event. A few logistics for today's webinar. It will last until 4 p.m. Other than today's presenters and panelists, and as well as our Rutgers team, you're all muted. So to communicate with us, please type your questions into the chat box. To find the chat box, look at the bottom of the screen and you will see a little bubble that says chat. And if you click on that, you can send your questions and comments to us. Please do not use the Q&A option there. Please send them through the chat and send them to all to panelists so that we can, all of us working behind the scenes today, can see your questions. A big thank you to my colleague Matt Drews here at Rutgers for his help today with the webinar. And I also wanted to let you know that we are recording the webinar today, and it will be available on the New Jersey Climate Change Resource Center website, which I will put into the chat in a moment. One certification maintenance credit has been requested through the American Planning Association. So if you need the certification credit, please reach out to us after the webinar. Today, we are pleased to welcome the authors of this wonderful new report. They include Marjorie Kaplan, Stephanie Murphy, and Mark Robson from Rutgers University, Jessica Paolini from Middlesex County's Office of Business Engagement, and although she couldn't be here today, Sara Kelemen from the University of Maine. In the interest of time, I won't go over their bios today, but I do encourage you to check them out on our website that will be put up with the recording. Again, I'd like to remind everyone to put your questions in the chat box and send them to panelists. And with that, I'd like to invite our first speaker, Marjorie Kaplan, to turn on her microphone and kick off today's event. Kick it away, Marjorie.
Good afternoon. Carrie, can you hear me okay?
We can hear you well. Thank you. Great.
Thank you. It's my pleasure to be here with all of you and with my co-authors to present findings from our recent study, the link to which I suspect you, Carrie's already put in the chat box. So the purpose of our study has been to better understand opportunities for natural and working lands with a focus on agricultural lands to sequester or store carbon for mitigating climate change by removing carbon dioxide from the atmosphere and storing it as carbon in vegetation and soil. The impetus for our work came from Peter Fury of the New Jersey Farm Bureau and Michael Catania, who was then the executive director of Duke Farms, who in late 2019 brought together the leadership of the New Jersey Department of Agriculture, the USDA NRCS's New Jersey State Office, and the New Jersey Agricultural Experiment Station, together with stakeholders, to discuss this concept. And today we'll delve into the mitigation potential of soil carbon in agriculture. We'll share an overview of payment for ecosystem service models, which we also use the shortcut PES, and we'll explore opportunities for New Jersey's agriculture sector. In addition to literature reviews, we conducted semi-structured interviews with more than 50 experts from federal and state agencies, NGOs, academia, and the private sector. We looked at ag tillage and grazing practices, but we also looked at other models, for example, forests, because these can qualify for farmland assessment and can provide additional opportunities as carbon sinks. We identified 45 considerations to address barriers, gaps, research needs and opportunities for agriculture in New Jersey. And today we're going to just highlight some of them. NJDEP finds natural carbon sinks are necessary for the state to reach its 2050 goal to reduce greenhouse gas emissions 80% below 2006 levels. In its 80 by 50 report, NJDEP views agricultural lands as part of the natural and working land solutions to address climate change. And although ag emissions represent less than 0.5% of New Jersey's greenhouse gas emissions, we'd be remiss if we didn't mention that there are many other ways, in addition to acting as a carbon sink, that agriculture can address greenhouse gas emissions and realize economic benefits. Some examples, things like on-farm use of renewables or manure management, reduced fertilizer. But our focus has been to look specifically at ag as a sink for carbon. And as you'll soon come to appreciate, this focus in and of itself is complex And with that, I'm going to turn it over to Dr. Stephanie Murphy, who will discuss the potential for soil to act as a carbon sink. So Stephanie.
Thank you, Marjorie. And thanks for everybody for participating today. I'll share with you a brief overview of carbon sequestration as a climate mitigation strategy. This diagram is a representation of the global carbon cycle with annual fluxes of fast cycling indicated, that is, changes that occur within a lifetime. Notice that soils represent a carbon stock about 4 times larger than plant biomass and 3 times larger than the atmosphere. Flow of carbon into plant biomass by photosynthesis is countered by plant respiration and soil microbial respiration. And increased carbon dioxide from human emissions can partially be negated by increased photosynthesis, but not entirely. Oceans also absorb some of the excess carbon dioxide, but acidify as a result with negative implications for marine ecosystems. Breaking down terrestrial numbers by land use, it's logical that forests have a particularly high potential for carbon sequestration due to lack of soil disturbance, amount and age of biomass storing carbon, and woody nature of much of the biomass, which is relatively resistant to decomposition. As land uses have changed and ecosystems disturbed, carbon storage in soils and vegetation has decreased, this being an additional human cause of atmospheric carbon dioxide increase. For mitigation, we need efforts to put more carbon in vegetation and soil to draw down atmospheric carbon dioxide. Next slide. So human activities, including agriculture and other land use changes, have decreased the stock of soil carbon, releasing much of the atmosphere as carbon dioxide. In addition to the carbon dioxide lost from soil and produced by use of fossil fuels, agriculture contributes other potent greenhouse gases, methane and nitrous oxide, to the atmosphere. Note the relative global warming potential of methane and nitrous oxide gases, which are often associated with agriculture. These relationships are useful in summarizing total greenhouse gas emissions as carbon dioxide equivalents. Differences over given time periods relate to the expected lifetime of the gases in the atmosphere. It's been estimated that agriculture accounts for about 10% of US greenhouse gas emissions, and as Marjorie mentioned, less than 5% of New Jersey's gross greenhouse gas emissions. New Jersey's forests, agricultural land, and wetlands are estimated to sequester 8.1 million metric tons of carbon dioxide equivalents, offsetting almost 8% of current greenhouse gas emissions. A preliminary analysis by NJDEP suggests that in New Jersey, an additional 2 to 3 million metric tons of carbon dioxide equivalents could be sequestered per year from natural and working lands through reforestation, avoided land conversion, and conservation management of agricultural lands. So this report focuses on the single aspect of reducing greenhouse gas emissions by sequestration on agricultural lands. Next slide, please. Much of the sequestration potential of agricultural lands is from soil's capacity to accumulate additional organic matter. The soil carbon pool, or stock, is determined by input of primarily organic matter, or biomass, minus the decomposition or respiration as CO2. Though input and decomposition processes are happening at varying rates throughout every day, changes are often detectable only on annual or decadal basis by decades. Okay. Concentration of carbon in soil and bulk density of soil are evaluated for whole soil profiles and then scaled up to field or landscape levels. When considering sequestration of carbon, we're mostly interested in the humified organic matter, or humus, a recalcitrant form of organic carbon, stabilized in complex form and often absorbed on mineral surfaces, resistant to further breakdown. Therefore, humus can be hundreds or even thousands of years old. Humified soil organic matter is considered slow or passive forms of carbon, and so sequestered long-term. By increasing its organic matter content, soil becomes a sink to sequester carbon in the humified organic matter fraction. Restoring and increasing soil's organic matter content through plant photosynthesis or soil amendment with organic byproducts on agricultural and natural lands are conceptually easy ways to draw down atmospheric CO2. Estimates of biophysical potential for managed crop or grasslands to store additional carbon varies. A global range of 2 to 5 gigatons of carbon dioxide per year has been suggested as possible maximums, assuming full adoption of best management practices. Rates are expected to decrease after decades as new equilibriums are approached, meaning that the maximum rate is not expected to continue as soils reach their full storage potential. Next slide, please. So we must recognize that native ecosystems, which in New Jersey were thousands of years in the making, are often near the quasi-stable equilibrium of soil organic matter. And disturbing the natural vegetation and landscape only depletes the stored carbon and contributes to greenhouse gas emissions. So maintaining these natural areas is in itself an effective strategy, where agricultural production is the managed ecosystem, replacing annual crops with perennial crops, having greater total biomass and below ground biomass throughout the year allows greater carbon of storage in that vegetation itself, as well as accumulation in the soil. Next slide, please. So as we've seen, preventing loss of soil carbon is a strategy, just as restoring or increasing stored carbon is. A good number of agricultural or land management practices are identified for their ability to increase carbon input to soil and or to reduce carbon loss from soil. With optimum conditions and crop genetics, greater biomass production will lead to greater inputs as long as residue is retained in the field. Cover crops also represent greater overall photosynthetic capture of carbon dioxide and input into soil. Similarly, converting to perennial crops, as just mentioned, including trees, not only increases inputs, but also avoids losses of carbon from soil. Reduced tillage practices have ability to both retain stored carbon and increase carbon input. Utilizing organic waste as amendments increases inputs. Restoring wetlands or wet areas that have been previously drained for agricultural use minimizes further loss of carbon from those areas. And careful attention to stocking density and movement of grazing animals on pasture or rangeland can result in both greater inputs and reduced losses of carbon in soil. Combining multiple practices increases the beneficial effects, and resulting changes, the degree of change are dependent on soil type and prior condition of the field or the soil, the climate, the crop, and combination of the practices that are implemented, and of course, time. Next slide. Summarizing the most common and effective agricultural practices for increasing soil organic matter or organic carbon stock are reducing tillage, selection of crop rotations, cover crops, or conversion to perennial crops, stable organic matter additions, and closing nutrient cycles by including grazing animals in the system. Next slide. So estimates vary and have significant uncertainty. This diagram is useful in comparing relative potential of different natural climate solutions for climate mitigation in the United States. Notice the bar shadings represent different price points in US dollars, with a maximum potential in dark green constrained by the requirement of compatibility with human needs for food and fiber. Reforestation and proper forest management have greatest potential by far. Avoided grassland conversion, cover crops, and alley cropping have greatest potential under the category of ag and grasslands, with amendment with biochar also substantial if higher dollar investment is achieved. Implementation of cover cropping can be done at relatively low cost. Keep in mind that more than one of these strategies can be implemented together for greater impact. Notice on the left side of the axis that beneficial effects of these different practices on ecosystem services are symbolized by the colored bars representing the beneficial effects on air, biodiversity, soil, and water. Next slide. In fact, increasing organic carbon in soil itself generates benefits to water, air, and biodiversity. Despite some lag time after implementation of best management practices on degraded soil, benefits in soil quality and crop response are often experienced even prior to observation of soil organic carbon increases. Especially for degraded soils, even small increases in soil organic carbon can have noticeable impacts on quality and functioning. Positive impacts cascade. Increasing input of soil organic carbon leads to feeding of soil organisms and building soil microbiome populations and diversity, development of soil structure, enhanced water holding capacity and permeability, erosion control, and crop yield, for example. Next slide. There are some concepts that must be taken into account when considering sequestration of carbon as organic matter in soil. It has to be recognized that there's an upper limit to carbon as organic matter in soil. In a mineral soil, that can maintain its equilibrium, its saturation level. Sequestration implies that carbon must be stored away for a long period of time. So the total input of carbon to soil is not assumed to be the total sequestered. Furthermore, to count towards climate mitigation, the carbon sequestered in soil must be additional to what would be happening anyway. And the carbon footprint of the added practice or amendment should also be accounted for in a life cycle assessment to assure overall negative greenhouse gas emissions. For purposes of research on management changes, on management practice effects, for incentive programs, or for climate mitigation carbon markets, soil organic carbon changes must be tracked. And the sampling and analyses to verify soil organic carbon values must be standardized and carefully conducted. Next slide. Models have been developed to quantify the processes and outcomes of a wide variety of soil management practices or situations. There are two of them are highlighted here. The first versions of the denitrification decomposition model consisted of 3 main submodels, which work together in simulating nitrous oxide and dinitrogen emissions. The soil climate thermal hydraulic flux submodel, the decomposition submodel, and the denitrification submodel. The major uses to the DNDC-based models are usually utilized for estimation of nitrous oxide emissions at regional or national scale and assessing the potential impacts of land use change on greenhouse gas emissions. Comet Farm is a decision support tool based on Century Descent model to estimate whole farm or ranch greenhouse gas emissions, taking into account specific climate, soil, and management factors. It allows evaluation of different options to assess potential for reducing greenhouse gas emissions and sequestering carbon, and so has been widely used and adapted for specific regions and crops to guide land managers in production decisions and carbon sequestration effects. That summarizes my input on the soil and plant sequestration of carbon.
Marjorie, you're muted.
I just unmuted myself. How's that? And I can see my slides had a little, they changed. Oh, wow, look at that. The colors went away. Well, we'll just have to wing it. Sorry about that, folks. So now I'm going to talk a little bit about the types of programs that have been evolving that can put the concept of paying for sequestration into action. So thanks, Stephanie, for your good discussion about these kinds of practices. So past programs are based on the idea that individuals or communities get compensated for undertaking actions that increase the provision of ecosystem services like water purification, flood mitigation, or carbon sequestration. And the co-benefits, in addition to what Stephanie talked about, can include improved public health, enhanced biodiversity, creation of green jobs, or urban tree planting in distressed neighborhoods. California and New Jersey, for instance, use co-benefits when they evaluate funding priorities for their cap and trade revenue investment. Compensation may take an outcome-based approach whereby you quantify the amount of greenhouse gas emissions reductions that you're achieving or amount of carbon sequestration, or a practice-based approach where programs pay for implementation of practices to sequester carbon or reduce greenhouse gas emissions. And the payment rates vary across programs. Both regulatory and voluntary markets drive the purchase of ecosystem services. We came up with a typology. We classified these programs into these three big buckets as compliance or regulatory-based programs, voluntary markets, and then practice-based incentive programs. Regulatory cap and trade programs can include the Regional Greenhouse Gas Initiative program that New Jersey participates in, and the California cap and trade program as examples. In these programs, a regulated entity like a power plant could meet their pollution reduction limits by reducing CO2 emissions on site, by having enough emissions allowances to cover their CO2 emissions, or in part by purchasing offsets. And there are two mechanisms that drive PEZ programs in this instance. The first is through offset projects that generate credits for sale. These are project-based greenhouse gas emissions reductions that occur outside of the capped regulated sectors. Offsets have to meet strict protocols that are established by the regulators. To date, there haven't been carbon offset protocols accepted for carbon sequestration in these regulatory compliance markets for production agriculture, with the exception of woodlands, for carbon storage benefits of reforestation, forest management, or avoided conversion of private forest land to a non-forest use. Conservation organizations have developed forestry offset projects, including on land in the Northeast, for compliance with the California program, but there have not been any forestry projects awarded offset credits under the RGGI program. At this time, the incentive for development of an offset project for the RGGI market appears weak, especially since allowance prices in California are higher than RGGI. The other mechanism for PEZ programs in these compliance markets is to use revenue generated from the sale of the cap and trade emission allowances to pay for ecosystem services. And indeed, the California Climate Investment Program uses cap and trade revenues for many programs, including those related to natural and working lands. Examples include wetland restoration, forest health, adaptation and resiliency for ranchers to switch to regenerative grazing, and the California Healthy Soils Program, which includes ag practices for farmers to sequester carbon. In New Jersey, the Global Warming Solution Fund Act does does carve out cap and trade revenue to support forest stewardship and tidal marsh restoration, but doesn't include ag practices for farmers. There's Maryland's water quality trading program, which sets up a public market for pollutant reduction credits to incentivize point and non-point sources of pollution to meet regulatory pollutant limits. So this is another form of a compliance-based system. Agriculture operations can participate through a nutrient trading program by generating nutrient credits with practices such as planting cover crops. This is not a program for carbon sequestration. Maryland is exploring adding carbon credits to its program, allowing farmers to stack nutrient and carbon credits would be what they're looking at. Pennsylvania has a program called REAP. It provides a tax credit in exchange for implementation of management practices on farms to help comply with its Clean Streams law. Again, the intention is for nutrient reduction, but these practices can include no-till agriculture, planting cover crops and the like, which also have carbon benefits. In voluntary markets, the next bucket we'll talk about, producers are paid for emissions reduction benefits of natural and working lands in the absence of a regulatory requirement. So in these markets, demand is driven by various factors. Universities can be credit buyers to achieve carbon neutrality goals. Regulations like the Carbon Offsetting Reduction Scheme for International Aviation are allowing offsets to phase as they phase into the program. Financial market drivers include institutional investors who are concerned about climate change and those who see it as a risk. In France, institutional investors are required to disclose climate impacts. You may have just heard the finance minister from the UK announced that they would be looking at this, moving to something like this as well. During COP26, this announcement was made. There are corporate social responsibility frameworks that are growing, like the Science Based Targets Initiative, where companies set emission reduction targets in line with a 1.5 degree future, and they report on their progress. Here you see some of the SBTI members that have a presence in New Jersey. And these initiatives result in businesses investing in their own supply chain to meet their targets. These supply chain emissions are known as Scope 3 emissions. Businesses are working to meet investor expectations and increase employee satisfaction. Corporations that source products from farmers pay farmers to implement practices like cover cropping or no-till ag and provide training, recognizing that helping their farmers suppliers address climate change through practices that can help with resiliency for them is actually essential to maintaining their own operations as well. The expectation we heard is that demand for carbon offsets in the voluntary market will increase, especially from tech, finance, and other industries that don't have natural assets or landowners they can work directly with in their own supply chain to address their greenhouse gas emissions. Voluntary projects often use third-party standards. You see a few of their logos here on the slide. Most often, these projects must meet these strict requirements, as Stephanie alluded to. The projects must be permanent, additional, verifiable, enforceable, and real. That's what these blue boxes mean. They call them paver requirements. In the regulatory compliance world, as I mentioned, offsets must follow these strict paver-like protocols at a minimum. In the voluntary market, these criteria can vary. Voluntary markets are evolving. Some are tailing requirements to be more adaptable to agriculture. Monitoring and verification is expensive. Quantification approaches vary. Farmers may be hesitant to sign on to long-term programs to address permanence, given how markets can fluctuate. And additionality is viewed as punitive to early adopters of sequestration practices. Generally, forest improvement and grassland livestock grazing models have operated where you find NGOs will develop projects with support from companies and foundations, and then these project developers provide technical and financial assistance to landowners who implement practices that often meet multiple ecosystem services. The landowner gets the financial benefits in terms of reduced operating costs. They often receive some of the income for the carbon credits they generate for sale. Representatives from across the ag sector are also participating in emerging marketplaces that will essentially facilitate matches between ag producers and credit buyers, such as the Emerging Ecosystem Services Market Consortium, or something called the B Carbon Initiative out of Rice University, as two examples. And now we'll talk a little bit about practice-based incentive programs. These award grants to farmers to apply conservation practices. In the California, Maryland, and New York state programs that we've noted here, the practices are for the most part known practices already supported by USDA and NRCS incentive programs, but state funds have increased support for these. Maryland state funds support expansion of their cover crop program, but Maryland's also researching other soil health practices with federal and NGO grants. The nonprofit Restore California program is a grant program supporting the same practices the California Healthy Soil Program supports. They raise dollars through donations from restaurants who voluntarily add a surcharge onto diners' bills. And with COVID, they've added in a member option for food and beverage enterprises. Ducks Unlimited has a program that's been funded by philanthropy and a federal grant. It integrates livestock on small grain and row crop farmland along with cover crops. The California programs and the New York state programs use the USDA Colorado State Comet Planner modeling tool Stephanie mentioned to quantify carbon and emissions reductions. California worked with the tool developers to tailor it for their use. New York State and Maryland are exploring options for modifications as well. Biologists at Ducks Unlimited run biogeochemical models of carbon stocks. These are not the only organizations that do this. These are just some examples from our work. But these practice-based programs are working to incentivize generational behavior change, and therefore they don't pay for practices indefinitely. Education plays a large role, including peer-to-peer learning. California funds a demonstration program as well as education of technical service providers. And so now as we move into describing some considerations for New Jersey agriculture, I want to just pause for a second to note a couple of things. Agriculture is important to New Jersey's economy. It generates more than $1 billion in cash receipts annually. While 1/3 of our farmland is preserved, and a recent analysis ranked New Jersey first in the nation for implementing programs to stem farmland loss, farm real estate values in New Jersey are, by some estimates, the second highest in the nation. More than half of our farms are leased. 67% are farmed by part-time farmers, which means farming is not their primary occupation. This indicates the remaining farmland we do have is at risk for development. And with climate change comes an added risk, for example, of soil loss due to, for instance, heavier rain events. So despite these challenges, we characterize opportunities for payment for ecosystem services for agriculture that could enhance carbon sequestration, improve soil health, and provide the benefits that Stephanie mentioned. And these opportunities can be pursued concurrent with addressing barriers and the gaps we identified. So I'm going to just highlight a few of the more than 40 considerations for New Jersey agriculture we reported, and then I'll be joined by my co-authors and we can have more of a conversation perhaps. Scientists all over are working to better understand soil carbon sequestration potential, including colleagues at Rutgers and NRCS New Jersey. We further want to acknowledge our NRCS colleagues who are leading development of a soil health strategic plan for New Jersey. Based on our interviews, we identified more than 10 key opportunities related to sequestration potential and quantification considerations. So I'm just going to note a few key ones here. One includes the idea of establishing an authoritative baseline of carbon stocks, and identification and assessment of priority areas for increasing soil carbon, and scenario analyses of potential carbon gain pathways on New Jersey ag lands, building upon research underway and working through continued collaboration with, between NRCS in New Jersey and our academic research partners. Another idea is to establish sentinel sites by county to evaluate agronomic practices and the influence of localized factors to improve modeling that would reduce field sampling expenses. It's important to determine the most appropriate conservation practices based on specific soil, terrain, ag type to assist the farming community in pursuing soil carbon gain pathways. And programs should consider the unique character and features of agriculture in New Jersey, such as the many specialty crops, relatively small acreage of many farms, and of course, our strong organic agriculture niche in our state. As mentioned, generating carbon offsets acceptable for compliance in the California Cap and Trade program through forestry-related practices and avoided conversion of forest land can be an opportunity for New Jersey landowners. Generation of offsets acceptable for compliance within the RGGI region for forestry-related practices on forest land located in New Jersey, although not likely, is a potential avenue for New Jersey landowners. In reiterating, there are opportunities for farmers and landowners to generate carbon offsets for the voluntary market that can include partnerships between conservation organizations and/or the private sector project developers and property owners to produce carbon offsets for sale in voluntary markets. Farmers can also receive direct support for conservation practices from corporations seeking to meet CSR goals if they're within the supply shed, that is, within the group of suppliers providing similar goods and services within the company's supply chain. Farmers can also help agri-input companies who may want to support the farms they sell their products to meet CSR goals as well. And as this story, I put a little headline in here from AgriPulse notes, corporations have committed to emissions reductions goals, but there's a deficit on the ag supply side, and there are not universally accepted protocols for how to measure ag emissions or how to reduce them. However, there are companies out there enrolling farmers in pilot programs, and you'll see this much more in the Midwest. And you can Google it and you can see they're out there. Traditional USDA NRCS practice-based programs like the Environmental Quality Incentives Program, the Conservation Stewardship Program, just to name two, have opportunities for carbon sequestration and could be leveraged for that. It was suggested that it would be good to develop a regional testing program for farm practices, conduct on-farm trials and more demonstrations to help farmers understand what practices work. We heard there's a need to better understand what level of payment farmers need for how long to get them to participate in programs in New Jersey. And based on all that we heard, we learned from California, New York, and Maryland, it became clear there could be an opportunity for establishing a New Jersey Healthy Soils or Climate Smart Resilient Farming program. And such a program can also be informed, we're certain, by NRCS's forthcoming Soil Health Strategic Plan for New Jersey. We heard it's important to quantify and communicate the economic benefits of practices to increase carbon. Interviewees cited the importance of quantifying and communicating the co-benefits from these payment for ecosystem services programs to build support. So for instance, the UCLA Fielding School of Public Health is developing a scenario tool for assessing the health benefits of conserving, restoring, and managing natural and working lands in California. We heard about opportunities to foster uptake and increase success of voluntary practice-based programs, including through showcasing projects. In California, eligible demonstration projects can also include those for additional practices for which a greenhouse gas quantification methodology does not exist. And so on-farm measurements are taken to demonstrate the sequestration potential. We also heard about the need to expand training of technical service providers in New Jersey for conservation practices to foster carbon sequestration. On financing practice-based programs, the California Healthy Soils Program and the New York Climate Resilience Farming Program allow participating farmers to combine USDA NRCS grant funds with their respective state programs. California does not require a cost share and pays twice the NRCS EQIP rates. We heard that county boards of agriculture in New Jersey are doing a great job with farmland preservation. And it was suggested they explore whether they have authority to fund stewardship practices. Another suggestion was exploring opportunities to prioritize state soil and water conservation grants for projects that can also sequester carbon. Other opportunities noted were table to farm models, like those of zero footprint that I mentioned. Another suggestion was the formation of a nonprofit carbon mitigation bank supported by the public or CSA members who might offset their emissions by donating funds to the bank that can be used by farmers to implement conservation practices. We heard loud and clearly from many sectors that the cost of equipment needed to change practices, such as moving from conventional tillage to no-till, is a barrier given their expense, and that a farmer may not be certain how well a specific piece of equipment might work on their farm. Considerations include a regional program where producers could work with Extension to test equipment on their land. We also were pointed to options for state grants, loans, or tax incentives like Maryland, New York, and Pennsylvania to provide for equipment purchases, lending, or rental, including provisions for trade-in or selling of equipment for producers implementing practices that enhance sequestration. And I want to just briefly mention here that one option that could have a sequestration benefit for adapting cropland vulnerable to flooding, for example, is conversion to forested buffers and or woodlands. So in New Jersey, this option may prove problematic in a scenario where a transition would be from modified ag wetland to silviculture. And in that scenario, it's not clear if from a regulatory perspective, if the modified ag land would be interpreted to be a wetland, even though it would be converting from one ag use to another. Preserved farms present another wrinkle in this scenario because they have deed restrictions that mean they must remain in agricultural use. So we find that some of these challenges we need to discuss. With respect to upland portions of preserved farms, we were told that clear guidance is needed to determine the amount of preserved farmland that could be converted to forestry, and if such conversion has to produce a timber crop, or if other management objectives can be realized, such as the provision of habitat for sensitive species, groundwater recharge, or other sorts of services, particularly in marginal agricultural areas with steep slopes or highly erodible lands. Thus, one consideration is to identify what policy or regulatory changes may be needed to help transition farms in the face of climate change, recognizing the competing priorities of ag food production versus provision of ecosystem services. And a novel concept posed by folks we spoke with was the idea of a whole farm easement approach, where farms would be valued for not only their agricultural values, but also their contribution towards soil health, carbon sequestration, species habitat, and wellhead protection. Lastly, an idea was posed of exploring whether funds that were allocated under the Preserve New Jersey Act of 2016, which includes projects that improve the resiliency of farmland soils, could be used to fund conservation tillage equipment for use on preserved farmland. So before we get to our discussion, I really have to mention that I have to thank all of the folks who participated in the interviews we conducted. We know that transitioning the farm community to safe COVID protocols has been a monumental task over the last year and a half or more. And in general, we really appreciate the folks that extended themselves to us during this time from all over the country. This work was done with the support of the leadership of the New Jersey Agricultural Experiment Station. And we want to acknowledge particularly Margaret Brennan, Wendy Kohick, and Brian Schilling. And we have to mention our wonderful colleague, Sara Kelemen, who couldn't be with us today, Sara is a graduate student at the University of Maine. And also we have to thank her graduate faculty advisor, Professor Rachel Chapman, who provided support for Sara's participation. And we would be remiss if we didn't mention the 3 distinguished scientists and thank them for the peer review of our work. Michelle Cavagelli of USDA's Ag Research Service and Professors Daniel Jimenez and Richard Lathrop at Rutgers University. And so I'm going to say that here is how you reach us. And while you take down our emails and are happy to contact us later today if you want, or any other time, I would like to invite Stephanie and Mark and Jess and Carrie all to put their cameras on. And I'm gonna stop sharing my screen, I think, if that would be okay. And I wanted to quickly pass it over to maybe Mark first and Jess, who haven't had a chance to speak. If there's something else we neglected to say that you would like to, or any other point you would like to drive home based on our work.
So thank you so much, Marjorie, for really giving a terrific overview of the report and for really doing so much of this heavy lifting to make this report a reality. I'm very grateful. And I think the thing that I'm most excited about for this report is the level of interest in all sectors, from the non-profit community, the agricultural community, and the industry leaders. And as Marjorie pointed out when she initiated the presentation, she talked about the importance of both Michael Catania and Peter Fury, the Duke Foundation and the New Jersey Farm Bureau, as being one of the catalysts and the facilitators for us to go into this report. As someone who grew up on a farm in Burlington County and who recognizes that for agriculture to remain viable and make a contribution to the environment in New Jersey, these are the kinds of measures that we have to take. These are the things our farmers need to understand. Farmers are business people, and so these women and men who are farming on a large scale need to know this information. What better place than New Jersey to adapt some of these kinds of techniques to their farming operations? So we just want to really reinforce the importance that we see as this being a bright part of the future for New Jersey agriculture.
Thanks, Mark. Jess, we haven't heard from you.
Yes, I'm here. Thanks for having me today. And thank you to everybody for spending the time joining us. One of the things that I wanted to emphasize, and Marjorie, you touched on it a bit, but I think it was one of the things that I was most surprised about in doing this research. You know, payment for ecosystem services. I thought going into this that the payment aspect would be a key motivator for owners and operators of natural and working lands to get involved in carbon sequestration and the delivery of ecosystem services. But really what we heard was a whole range of motivations, and the payment was not the main driver of participation. It was owners who care about the legacy of their land. It was farmers who are innovative and forward thinking and who are, you know, seeing the impacts firsthand of climate change and recognizing that they need to make a change in their practices. For ranchers in the Midwest, it was having an opportunity to label the products that they're producing as being more sustainable and thereby maybe reaching new markets. For large landowners in California, it was an opportunity to use some of the funding for other environmental initiatives, but that payment that you would get, whether it's per ton of carbon sequestered or whether it's for a specific practice, that was not the main driver, and that was eye-opening for me to see that there's all of these other motivations. But it also speaks to one of the recommendations that Marjorie shared, where there's a need to better define what the incentives are, what the costs are, and to better understand the different programs that are available. How much would you be earning from these programs, whether it's per ton sequestered, whether it's for implementing a particular practice. There wasn't, looking at all of these programs, it wasn't like every single program was paying between, you know, $20 and $40. There was a really wide range of payments that were being made, and a lot of participation was being driven by other factors.
Hey, Jess, did you want to talk at all? One of the things I didn't really talk about was the marketing opportunities. Seeing as now that that's what you do, economic development.
Yeah, I can, a few of them. So one of them I touched on, for example, the Audubon Conservation Ranching Initiative. They work with ranchers in the Midwest who are producing beef, and one of the drivers for ranchers to participate in that program is that the beef that they sell on the market is certified as being produced on bird-friendly lands. I believe, Marjorie, correct me if I'm wrong, but I believe there's an aspect to some of the programs in Pennsylvania where they put signs in the fields of farmers who are participating in REAP and other programs. And California also has a website database that they've put together. It's, I believe, very much in the early stages, and they'll be adding more of their participating farmers, but it's a website where you can go on and you can see all of the farmers that have adopted these different practices. And for consumers, you know, a lot of what's driving the corporate social responsibility initiatives is the desire of consumers to purchase products from companies that align with their personal values. And same goes for individuals who are purchasing products from farms. This gives them an opportunity to support those farms that are aligned with their values. So I think that's another, you know, important aspect, a way that you could increase participation in these programs is by offering certification or marketing opportunities so that consumers are informed and farmers or landowners could potentially reach new markets.
Thanks. So, Carrie, do we have any questions?
Yeah, we do.
In the chat box. My mouse is so sensitive, I'm afraid to move it. Well, now I'm not sharing my screen, so it doesn't matter, but.
Yeah, thanks, Marjorie. We had a few questions. So
I think they're farmer questions. They're going to be more for Steph and Mark.
I was just going to say, yeah, exactly. I think these definitely for Stephanie and Mark. Our first question was about no-till farming. So what was asked was, no-till farming makes extensive use of herbicides and is predicated on using genetically modified herbicide resistant crops. Will this technique help prevent erosion and soil loss, but does it really increase soil organic carbon or just keep existing topsoil in place? Did you get that question?
I think it's been shown that soil organic carbon does increase under no-till. There are definitely trade-offs. You know, there's no perfect situation. As I told my class many times this semester, that you know, there is a specific purpose to tillage. There are reasons why farmers till the soil, and one of them is weed control. So if we do drop out tillage as a weed control practice, then we have to deal with that issue. And as you said, use of herbicides is a consequence of that. But yeah, the increase of carbon in soil has been shown. It tends to be more concentrated at the surface. As you can imagine, you're not tilling in the crop residue into the plow layer if you're not tilling. So you do get a gradient of organic matter from the surface in that kind of situation. But because you're aerating the soil to a lesser degree, which happens during tillage, that helps to conserve more organic matter in the soil. Mark, do you have anything to add to that?
No, I would certainly agree, Steph. And the fact is that just by the mere practice of no-till, where we keep the residue right in the plow layer, it's an opportunity for us. And even though we see, for instance, the question discuss things like, let's say GMO corn or GMO soybeans, where we've gone ahead and killed back the weed species that are competing, that still adds some OM to the soil, and we don't see this constant turnover and chance. As you know, New Jersey soils are so, in many places, so light in organic matter. We used to tease and say that, in South Jersey, we measure organic matter in ppb. And while it's probably not that extreme, this is one tool, and as Stephanie points out, the research is pretty supportive of the fact that this practice will maintain and in some cases increase OM.
And just that erosion control factor is important too, because when you think about erosion, it's happening right at the soil surface. And so organic matter is, or the soil that is eroded is going to be that soil that is most enriched in organic matter. So that conservation aspect of no-till, keeping the residue on the surface, protecting that soil surface, minimizing runoff, and increasing infiltration, all those factors are also really important, to keep the soil in place, as mentioned.
Thank you both. So another question we had about the report was that one of the impacts of agriculture is animal-based food systems, particularly grain-fed beef. So there's a question about whether there's an effort to address this use of land as part of carbon sequestration, reforestation, or renaturing.
Well, I could just briefly mention that I think a lot of we spoke to several people in the grazing world, and the whole there is rotational grazing, where you're not feeding grain, but they're natural, adaptive multipaddock grazing is a regenerative agriculture practice, and so it's moving people in the direction of putting livestock on the land, moving them quickly, letting them intensely eat, but then move it along, and it's much better from a sequestration potential, and I think the net out on the emissions is in a positive way. Is what I mean. I don't know if anybody else wants to add anything. Steph, do you want to?
Oh, well, and as I mentioned too, that it closes the cycle. We've tended to get to this situation where we have crop agriculture in certain places and animal agriculture, separate, not on the same farm. And so we haven't been able to, in those cases, complete the cycling of nutrients. We're harvesting away product and not returning wastes to the fields or to re-enrich or sequester carbon in those cases. But if we can move back to, as Marjorie mentioned, this rotational grazing, a carefully managed rotational grazing system, where we're utilizing all that carbon that's being fixed by photosynthesis, and returning nutrients through the animal's waste back to those fields. We're closing that cycle to some extent, and really making it more like mimicking a natural ecosystem cycle. I hope that helps.
That was great. Thank you so much. And on behalf of all of us here at the New Jersey Climate Change Resource Center, we'd like to once again thank Marjorie Kaplan, Jessica Paolini, Stephanie Murphy, and Mark Robson for being on our panel today. And we hope that you will all join us for our next Climate Academy event. Please look for announcements in your inbox or on the New Jersey Climate Change Resource Center website. And that concludes today's event. Thank you again for attending.
Thank you.
Thank you.